Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy.
So next up we're going to talk about integrals with the natural log ln. Okay, this is a very fun concept. So let's first deal with this problem right here. Number 1. If I have the integral of 1 over x dx, how would I solve this? There's two ways you could do this. The first way you can say is this. 1 over x. Can't I write this as x to the negative first power dx? In other words, you have an x to the first in the denominator. You can rewrite it as x to the negative first. Yes, this is technically legal. This is fine. The problem you're going to run into with this, though, is when we do the power rule. What's this integral power rule? Well, I would add 1 to the power. Negative 1 plus 1 is 0. So you'd get x to the 0. That's not a problem, actually, because x to the 0, that's actually just 1. The problem is when you divide by the exponent, which you do, you're going to get divided by 0. You can't divide by 0. This whole thing is wrong, which is funny. So instead what you need to do is you need to recognize this as a red flag. Whenever you see 1 over x like this or x to the negative first power, you need to recognize that this is a very straightforward integral. It's the integral is natural log of the absolute value of x plus c. That's the final answer. Now let me talk about where this comes from. So first of all, why is it natural log of x? Well, because think about derivatives, because you can always check your answer to any integral with the derivative. If I have the natural log of x and I ask you to take the derivative, hopefully you remember this, it's 1 over x. That's the original problem. That's the integral. So naturally, going reverse, it should be natural log of x. Now, where does this absolute value sign come from? That's a great question. I'm debating whether or not I even want to tell you because it's kind of a confusing definition, but maybe two of you will understand it and it'll justify me doing this. But let me first draw the function 1 over x. It's a function that looks like this. I'll draw it in red here. It has a vertical and horizontal asymptote at x equals 0 and y equals 0. This is the function y equals 1 over x in red. Now in blue, I'm going to draw the function for y equals the natural log of x. It's this function right here. Y equals natural log of x. Now here's the problem. 1 over x, my original function, that has a negative side to it. I can plug in negative 2, negative 3, negative 4, whatever, into 1 over x. I cannot plug in negative numbers into natural log of x. Because you can even try it. Plug in natural log of negative 2 in your calculator. Your calculator is going to yell back at you, error, because you cannot take the natural log of negative numbers. So that's why we say absolute value, because when we do that, now we include the negative values, and now we encompass the entire domain of the function. If that definition is confusing to you, luckily you never have to memorize the explanation. You just need to remember that whenever you see 1 over x, it's equal to natural log of the absolute value of x. Absolute value. The other thing you can imagine, just like for e to the x, if I have 1 divided by u, the integral of 1 over u du, like in other words, I did some u substitution that left me with a u in my denominator, just like this, then this integral is equal to the natural log of the absolute value of u plus c. And then the last step would be plugging in for u. Let's look at some examples. Number 2. I have the integral of, let's say I have 1 over negative 3x plus 4 dx. This is a u substitution. Why? Because would be quotient rule if this were a derivative. But since it's an integral, it's a u substitution. Notice the Goldilocks method isn't very clear here what we choose. I'm just going to tell you, make your u negative 3x plus 4. Just make it the denominator. So du dx, the derivative, would be negative 3. And then again, I need to solve for dx. So du is equal to negative 3 dx. Divide both sides by negative 3. So we get du divided by negative 3 equals dx. Great. And now I'm going to plug in for everything here. I have the integral of 1 divided by, the denominator is just getting replaced with u. And then dx is getting replaced with du over negative 3. Now, this is something we've seen pretty much all day. This negative 3 in the denominator, what am I going to do with that? That's right, kids. I'm going to say it's a negative 1/3 out in front of my integral because it's a coefficient, and the 3's in the denominator. So the integral of 1 over u du, And again, this is the exact same thing we just saw a second ago. You say u to the negative first power du, and then you cross it out because you remember that's not what we do here, because you would get u to the 0 over 0 if you do power rule. Instead, this is negative 1/3 times the natural log of the absolute value of u plus c. And we're not done yet because we still have to plug in for u, which u we said was negative 3x plus 4. Final answer will be this: negative 1/3 times the natural log of the absolute value of negative 3x plus 4 plus c. And there we go. Any questions on that one? Okay, I have one more for you guys with natural logs. And by the way, this is my favorite integral out of any integral in the world. It's the integral of 1 over x natural log of x dx. This is my favorite one. It's actually really fun. So I'm debating whether or not I want to do the right u substitution or the wrong u substitution, because this one's not obvious. So I'm going to ask for a member from the audience to tell me what the u should be. And whatever you tell me, whether it's right or wrong, I'm going to do it. So I need a volunteer.
Is it ln of x?
Oh, okay. ln had her own TV show, which got canceled. This is the natural log. And yes, I make that stupid joke every time because my high school teacher made it. So naturally, I do too. I'm not going to tell you whether natural log of x is right or wrong. You guys are going to tell me, because you know what we're looking for, if it's right or wrong. So then du dx, the derivative of natural log of x, is 1 over x. Now I need to solve for dx. There's a couple ways I can do it. I'm going to do it the hard way. The easy way is just cross multiply. X du equals dx times 1. This is easy because then you get dx right away. But let's say you miss this. I want to say what you do if you miss this. What you would do is what we've been doing all day. Du equals 1 over x dx. And now at this point, there's, again, an easy way and a hard way. The hard way is to divide by 1 over x on both sides. This gives you a complex fraction scenario like we talked about earlier, where you take the reciprocal, and I don't want to talk about that because it's confusing. The easier thing to do, to get dx by itself, multiply both sides by just x. The x's cancel here. The right side's good. The left side you have x du, and the right side you have dx. Regardless of whether you do the cross multiply method that I said from the get-go, or you did this kind of longer, roundabout way of doing it, you're going to get the same answer. Dx equals x times du. Any questions with that? Okay. So now where are we? We have the integral of the numerator stays the same, 1. The x in the denominator we do not touch, but the natural log of x, that gets replaced with u. And we said dx just got replaced with x times du. So question, did the x's cancel? Yes, they do. This x is in the numerator, that x is in the denominator. Great. We have the integral of 1 over u du, which again, this is very straightforward. It's just the natural log of the absolute value of u plus c. Now the last thing I'm going to say is we need to plug in for u. And we said u was the natural log of x. So does that mean the answer is the natural log of the absolute value of the natural log of x plus c? And the answer to that question is yes, and it looks silly, but this is my favorite integral in the world. And now I get to share it with all of you, which is the true gift of Thanksgiving. One more thing I want to mention real quick here. Notice the outer natural log gets the absolute value bars. The inner parentheses here, you can see these are parentheses. The inner ones are not absolute value signs. Does everyone see that? I'll take silence as a yes. Okay, great.
Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.